Good morning. I hope, as always, that you're all staying healthy and well. I still continue to miss you all so much and can't wait until I get to see each one of you. So today we're starting the last section or lesson of Unit 9 on systems of equations, and we're going to be looking at wind and water currents. I'll just read this paragraph to you so that you can follow along as we go. It says, suppose that you can paddle canoe at the rate or speed of 3 miles per hour in still water. That means without a current. If you paddle downstream on a river with a current 1 mile per hour, your speed is increased to 3 plus 1 or 4 miles per hour. So you're going to be able to go a further distance in the same amount of time. If you paddle upstream against the current, your speed is going to be reduced to 3 minus 1 or 2 miles per hour. So you're going to be able to go a shorter distance going against that current. Since the current increases your speed downstream by as much as it decreases your speed upstream, you might think that the current has no effect on the total travel time. However, the calculations below show that the current actually increases the total time for the round trip and decreases the average speed for the round trip. Suppose you travel 12 miles per hour, or just 12 miles downstream and 12 miles back upstream. The time for each trip can be found by using the relationship time equals distance divided by rate, which is another form of the basic distance formula of distance equals rate times time. So now let's look at the chart here. With no current, we know that we're traveling at 3 miles per hour for 4 hours. It's a total distance of 12 miles. Upstream, 3 miles per hour, no current, takes 4 hours, total distance 12 hours. If you look below that, you get the total distance is 24 miles round trip, 12 miles each way. The total time, it took 4 plus 4 or 8 hours. The average speed would be 24 divided by 8, which would give you 3 miles per hour. However, you see in the next column when that 1 mile per hour current is added, going downstream, remember it's 3 plus 1 or 4 miles per hour, divided by that distance, which is 12 divided by 4, it takes you 3 hours. When your rate going upstream, it now becomes 3 minus 1 or 2 miles per hour because it takes you go less distance in that same amount of time. It's still 12 miles, but divided by 2, your rate of 2 miles per hour gives you a total of 6 hours to get back upstream. So you'll notice the distance is still the same. 12 plus 12 is 24. However, your time now takes 9 hours. And when you divide that 9 hours, the 24 miles by the 9 hours, it now, your rate has become 2 2/3 miles per hour. Okay, so these next 4 things are going to illustrate what we're going to be using when we do some problem solving on the next side. The principles illustrated above apply to wind currents as well as water currents. Okay, so you got to remember if we're talking about airplanes, wind, water currents, boats. Thus, it says R equals the rate of the plane when there is no wind. Or obviously it means the current of the boat when there's, when it's still air, okay? W equals the rate of the wind, okay? Now, this is the one we're going to be coming back to. R plus W is the rate of the plane flying with the wind, or the rate of the boat with the current. So it's kind of just replacing the word boat with and plane and talking about the wind and the current. So this is when you're going downstream. R minus W is going to represent the rate of the plane flying against the wind, or the rate of the boat against the current, which means upstream. All right, so let's see if we can apply this to some of these problems on the back side. Practice. A jet can travel 6,000 kilometer, the 6,000 kilometer distance between New York and Paris in 6 hours with the wind. with the wind. The return trip against that wind takes 7 hours and 30 minutes. Find the rate of the jet in still air and the rate of the wind. Okay, so we know that rate times time equals distance. And we're going with and we're going against. So we just learned that when we're going with the wind, we are using R plus W with the wind. So our rate is R plus W. What is our time? 6 hours. What is our distance? 6,000. Against the wind, we learned that that's R minus W. What was our time? 7 hours, 30 minutes, or 7.5 hours. We're going 6,000 kilometers again. Okay, so now we're going to look at these equations and see what we have here. So we have with the wind, we have 6 times, I'm just rewriting this as 6 times R plus W equals 6,000. Well, let's go ahead and get rid of this 6. Well, before we do that, let's look at the second equation. So this one becomes 7.5 times the difference of R and W equals 6,000. Now, let's go ahead and clean these up. That's our next step. So to do that, I'm going to take and divide both sides by 6. And that's going to give me R plus W equals 1,000. Then I'm going to take this next equation and I'm going to divide it by 7.5. And that's going to give me R minus W equals, that does go in evenly, I believe it's 800 times. Now, we want to solve in terms of one of these unknowns. You can convert one and use substitution, or you can use elimination. I'm going to go ahead and use elimination, and I'm going to eliminate W by adding 1R plus 1R is 2R, W plus negative W is gone, and 1,000 plus 800 is 1,800. So now I'm going to divide by 2, and I'm going to get R equals 900. What is 900 representing? The rate of the jet. 900 kilometers per hour is how fast the rate of the jet can go. Is the jet in still air. How do we get the rate of the wind? That's the second question. Well, that's our W. Go ahead and decide where you want to substitute it into. I'll just take it and I'm going to substitute it in right here to that R. So instead of R, I'm going to get 900 plus W equals 1,000. I'm going to solve for W by subtracting 900. I'm going to get W equals 100. That is the rate of the wind. The wind is 100 kilometers per hour. Wind rate. Okay. All right. So hopefully that makes some sense. Let's try another one and see how that one goes. And yeah. Okay. So number 2 says, with a tailwind. With a tailwind. A helicopter traveled 300 miles in 1 hour and 40 minutes. The return trip against the same wind took 20 minutes longer. Okay, with a tailwind, that tailwind's at the back of that helicopter. It's making it be able to go further in that same amount, faster in that same amount of time. Okay, find the wind speed and airspeed of the helicopter. Okay, so we're still doing rate times time equals distance. Okay, and we're going with and we're going against. And when we do with, we go R plus W. When we go against, our rate is R minus W. Okay, now let's talk about our time. I want a little more room here. We know that the time with the tailwind was 1 hour, 40 minutes. and 1 hour 40 minutes is equivalent to 1 2/3 hour, which is equivalent to 5/3. So I just like to deal with improper fractions for that. Okay, if the return trip against the wind took 20 minutes longer, this is going to be 1 hour 40 minutes. Of course, plus 20 minutes is going to give us 2 hours. So that's going to be 2. What was our distance? 300 miles. Okay, we're going to do the same thing again. We're going to take these equations and we're going to try to convert them so that we can use elimination or substitution. So I'm going to take R plus W. I'm going to multiply it by 5/3. It's my distance equation going with the wind equals 300. Well, first, let's get rid of, you know what? We're going to have to get rid of the 5 and the 3, so the 5/3. So there's no point of multiplying by 3 and then dividing by 5. Let's just multiply through by the reciprocal of 3/5. When I do that, this all becomes 1, or R plus W, and then I'm going to end up with 900 over 5, and 900 over 5, 5 does go into 9 one time, into 48. So R plus W equals 180. So we've done that equation. That was our top one. We brought it down here. Now let's do this one. Again, it's 2 times the difference of R minus W equals 300. I'm going to divide by 2. And I'm going to get R minus W equals 150. Now I have my 2 equations. I have R plus W equals 180 and R minus W equals 150. I'm going to eliminate again. I'm going to eliminate W. So I get 2 plus R, or not 2 plus R. R plus R is 2R equals 180 plus 150 is 330. I'm going to divide by 2. R is going to be 165. What did I find? The wind speed or air speed of which one? I found that I found the airspeed. That's what I found. So that is 165 miles per hour. Let me abbreviate that correctly. So that's my rate. I can take that rate again, and you can choose where to put it into. I'm going to put it into the first one. So I get 165 plus W equals 180. Subtract 165. And I found that the wind was 15 miles per hour. Okay. I only have a couple minutes left, so I'm going to go ahead and stop here, and then I'll start on part 2 with the next video. See you back in a few minutes.